Okay, this is example 2.7. You have an airplane and it's going to take off on a runway. So it needs 20 seconds to take off from a runway, and the length of the runway is 500 meters. What was the acceleration of the airplane, assuming the acceleration is constant? And what's its final speed? Okay. So if you recall from example 2.6, we said that if the object we're looking at, it starts at rest. Okay, so that would mean that the initial velocity is equal to 0. Then the distance that it travels is 1/2 at squared. We don't need to worry about an initial velocity or initial speed because that's equal to 0. So the distance is just 1/2 times the acceleration times the time elapsed squared. Okay. Well, in this case, we know the time, it's 20 seconds. And we also know the length of the runway, 500 meters, right? So we know this length, the distance is 500 meters. And we know how much time it takes, it's 20 seconds. So it looks like if you look at this formula for distance traveled, we have everything that we need to find the acceleration. We just need to manipulate the equation, do a little algebra. So the first thing I'm going to do is I'm going to multiply both sides by 2. Let me show you this very carefully. I'm going to multiply both sides by 2. Okay, see, I just showed that it's multiplied by 2 on both sides. Actually, I'll put this in parentheses as well. But I'm also put the half in parentheses to point out that 2 times a half is 1, right? So that means we just have 2d. Now I'll get rid of the parentheses, is equal to at squared. We're trying to find the acceleration. Remember, the first question is what's the acceleration? That's a. So we're going to divide by t squared now. If I divide both sides by t squared, look what happens. T squared over t squared is 1. So now I just have acceleration. So I'm going to rewrite it over here as acceleration is equal to 2 times the distance traveled divided by the time elapsed squared. Okay, so now we can put in all of our numbers. 2 times 500 meters, that's the length of the runway, divided by 20 seconds squared, right? So that's 1,000 meters over 400 seconds squared, right? So we square 20 to get 400, and we square seconds to get seconds squared. So it looks like we got about 2.5 meters divided by seconds squared. Remember your acceleration units, distance traveled or displacement divided by units, time units squared, right? So meters per second squared. So we've got the first part. Then it asks us for the final speed. So now we're going to come back to this idea. What is acceleration? Well, acceleration is the change in speed or the change in velocity or the change in time, right? That's v2 minus v1. That's our final speed over our initial speed. If we're starting, at rest, we generally start the clock. That 20 seconds gets counted from time equals 0. So, delta t is really t2 minus t1, but t1 is 0. So we'll just call it t for t2, So v2, we're going to finally be moving. We're trying to figure out what that is. We want to know what this is. We do know it's starting at rest. So that just means it's going to be v2 over t, right? Because v1 is 0. If you're starting from rest, your initial velocity is 0. You're not moving at the beginning. So that's 0. So you just have v2 over t. We know the acceleration from part A. We know the time from the question. That allows us to find the velocity. So A equals v2 over t, multiply both sides by t. So t over t is 1, and that gives us v2. So v2 is, t times a. Typically, people write as a times t. And that would be 2.5 meters per second squared divided by 20 seconds quantity squared. I'm sorry, to the first power. Getting a little ahead of myself there. Okay, times 20 seconds. So that would be 50. We lose one of the seconds in the denominator down here. and we just have meters per second, right? So there's your final velocity. When it takes off, it's moving about 50 meters per second, which is about 120 miles an hour, 110, 120 miles an hour. Okay, so a little bit about the dimensional analysis. I know I kind of showed that right here, but it's meters divided by seconds squared times seconds. So if you have seconds squared in the denominator and you have seconds in the numerator, this one cancels with one of those and you get 1 over seconds. So you have meters divided by seconds.